Hello students. Today we will discuss another important name reaction, and the reaction is Cannizzaro'S reaction. Here only aldehydes gives this reaction, and there is a filter too. Aldehydes which does not have alpha hydrogen. So aldehydes which are not having alpha hydrogen, when they are treated with concentrated alkali like NaOH, KOH, so they undergoes disproportionation reaction. They undergoes disproportionation reaction. Disproportionation reaction means that is it is self oxidation reduction, means same molecule will get oxidized and as well as reduced. Let our aldehyde is formaldehyde. See, there is no carbon adjacent to the functional group. It means the adjacent carbon to the functional group is called alpha carbon. Here there is no alpha carbon, and the hydrogen remains linked with the alpha carbon is called alpha hydrogen. So this molecule does not have alpha hydrogen. So this will undergo the Cannizzaro's reaction. So when formaldehyde will be treated with concentrated NaOH, so one molecule of the formaldehyde will get oxidized while another one will be reduced. See, as we know, there is a trick to predict the product of after oxidation is that we must add oxygen in between the stressed carbon and hydrogen. See, this carbon is having stress because is linked with the electronegative oxygen. So we will add one oxygen in between the stressed carbon and hydrogen here, and other molecule will be reduced. As you know, during reduction, two hydrogen atoms are consumed. So here one of the pi bond breaking occurs, and as we are breaking the bond between carbon and oxygen, one hydrogen forms bond with the oxygen, other with the carbon. In this way, we'll get the alcohol and carboxylic acid. See, medium is alkaline. In alkaline medium, acid cannot exist. So the end product will be sodium formate and methanol. So this reaction is a Cannizzaro's reaction. Although remember that the reaction means Cannizzaro's reaction, this best proceeds with aromatic aldehydes. This one is best proceed with aromatic aldehyde. So we'll write the reaction taking the aromatic aldehyde. Let our aldehyde is this. It is benzaldehyde. See here in benzaldehyde, thus the alpha carbon is here. The adjacent carbon to the functional group is alpha carbon. But this alpha carbon has already formed 1, 2, 3 and 4 bonds. Means there is no hydrogen over the alpha carbon. So this will undergo the Cannizzaro'S reaction. Here, this is another molecule of benzaldehyde, and now is treated with concentrated alkali NaOH. So one of the benzaldehyde molecule will get oxidized while other one will be reduced. So during oxidation, as discussed earlier, we'll simply add oxygen in between the stressed carbon and hydrogen, while the another molecule will be reduced. See, we'll break one carbon oxygen pi bond and one hydrogen forms bond with oxygen, other with the carbon. See, again here we obtain here benzoic acid and benzyl alcohol. As the medium is already alkaline, so acid cannot exist, and here we'll get the salt. Means our end product will be sodium benzoate and benzyl alcohol. So this one is the Cannizzaro'S reaction. Now we will discuss that what's the mechanism, how the reaction occurs, this reaction. So see here what happens. The alkali NaOH will dissociate, will produce Na plus ion and OH minus ion. Now here it is benzaldehyde molecule, and as we know, aldehydes and ketones usually undergoes nucleophilic addition. See, this CO bond is already having a polarity, and we know that the electropositive carbon is comparatively more reactive center and therefore becomes more susceptible for the nucleophilic attack. So the OH minus ion furnished by the dissociation of NaOH will attack to the electropositive carbon first. Here these electrons will shift towards the oxygen. Then here single bond will left in between the carbon and oxygen. This oxygen will become now negative charged, and this OH will form bond with the electropositive carbonyl carbon. We'll get this type of species. Na plus ion are still in the medium. Now the anion thus formed will attack another benzaldehyde molecule. Again, in this case, here there is a polarity. The carbonyl carbon is having partial positive charge. Now, Na plus ion is lying in a medium. So, under the influence of these ions, here electromagnetic effect occurs, means these pi electrons shifted over the oxygen, electronegative oxygen, and at the same time here the hydrogen comes out in the form of hydride ion and combines to electropositive carbon of the carbonyl group. See, this one is the turning point of the reaction, and here this is hydride ion shifting occurs. As the hydrogen takes both the electrons of CH bond, so carbon will become electron deficient. So in order to maintain the compensate the deficiency of the carbon, the extra electron of oxygen shifted in between carbon and oxygen. Here we will get C. Now over this there is the OH, and as the two electrons come back in between the carbon and oxygen, here double bond will form. We will get here benzoic acid. Now as the hydride ion shifted over carbonyl carbon, so here this will form bond with the hydride ion. Now single bond will left in between the carbon and oxygen will acquire now negative charge. The Na plus ion which is lying in the solution, they will form bond with it. So in this way we'll get here a alkoxide ion. Now what happens here? There's a rule that whenever this type of condition is here, so in order to, here benzoic acid is obtained along with the alkoxide ion, and we know that the alkoxide ion is very less stable in comparison to the carboxylate ion. So in order to form more stable pair of compounds, here proton exchange takes place. See, what actually happens here? The benzoic acid loses its proton, and this exchange occurs here. The H plus moves to this electronegative oxygen, and the Na plus comes with this electronegative oxygen, and as a result here we will get C double bond O, and sodium benzoate is formed. See, benzoate ion is comparatively more stable than the alkoxide ion. So in order to obtain the more stable pair of compounds, here proton exchange takes place, and now the H plus shifted over this electronegative oxygen, and we will get the benzyl alcohol. So see here a proton exchange occurs in order to get the more stable pair of compound. Here the compound was benzoic acid and alkoxide ion, sodium alkoxide. Now alkoxide ion is unstable, so in order to get the more stable benzoate ion and benzyl alcohol, this proton exchange come into the existence. Is it clear? Now this, if the Cannizzaro'S reaction may occur in between the two same molecules and can also take place between the two different aldehydes. Let one of the aldehyde taken is, it is what? Formaldehyde. And the another aldehyde taken, it is benzaldehyde. And both the aldehydes are not having alpha hydrogen and are treated with concentrated NaOH. Again, one of the molecule will be oxidized, another one will be reduced. And this time the Cannizzaro's reaction occurs in between the two different aldehyde molecules. So the reaction is called cross Cannizzaro's reaction. If both are same, reaction is both the aldehydes are same, reaction is Cannizzaro's reaction. If both the aldehydes participating in the reaction are different, then it is cross Cannizzaro's. Remaining process is same. One molecule will get oxidized, another one will be reduced. Remember one thing, if one of the aldehyde taken is formaldehyde, so it is formaldehyde which will get oxidized exclusively. So here the product formed will be, see, oxidation of formaldehyde will occur and we will get here a sodium formate along with the another benzaldehyde molecule will be reduced. So here we will get the another product, benzyl alcohol. Remember this point that whenever one of the aldehyde is formaldehyde, so sodium formate is formed exclusively. Moreover, remember one more thing, that the Cannizzaro's reaction may take place within the same molecule also. And then see, let the aldehyde or molecule is HC double bond O, C double bond O and H. This is glyoxal. This is the general name. Otherwise, it is ethane 1,2-diol. See, functional group at adjacent carbon, means this doesn't have a alpha hydrogen, and when this molecule is treated with concentrated alkali, so as per the reaction, Cannizzaro's reaction, one functional group will be oxidized while another aldehyde group will be reduced. So here I will add one oxygen in between the stress carbon and hydrogen, and at other molecule, other aldehyde group, there will be a reduction. So one carbon oxygen pi bond breaking occurs, one hydrogen forms bond with the carbon, another one forms bond with the oxygen. See, acid is formed, but medium is alkaline. So in acidic medium, in alkaline medium, acid cannot exist, so you will get the salt. So see here, the disproportionation reaction occurs within the same molecule. So this one is example of intramolecular Cannizzaro's reaction. Is it clear?